Hi, so let's continue with where we left off previously in the stagnation pressure, dynamic pressure, and static pressure. Let's go to example 1-4 on page 14. Okay, it says that in a oil pipeline, so first of all, the first thing you catch is that it is an oil, okay, and it has a flow velocity of 3 meters per second. Means you are talking about flow of fluid. So naturally, you straight away think about the stagnation, static, and dynamic pressure. Okay, so the velocity is 3 meter per second, and the pressure is 25 kilopascals. This means that your static pressure is 25 kilopascal. Okay, the density is given as 875 kilogram per meter cube. So determine the dynamic pressure and the total pressure. Okay, the dynamic pressure will be half rho u square. So it is half of 875 and square of 3. This will give us 3937.5 pascals. Okay, 875 times half times 9, correct. And the total pressure, which is the stagnation pressure, will simply be an addition of dynamic and static. 3937.5 plus 25,000. The answer will be 28.937 kilopascals. Okay, you're supposed to express in kilopascals. So this is the example of these pressures in flow. Next, we will actually be talking about the next section in the lecture notes, that is called pressure head. Okay, one very core idea is that head, right, is a measurement of pressure. Okay, is a measurement of pressure, but instead of pascals, now it is in a certain length of a fluid. Okay, and this fluid, right, must not be mixed up with the flow, the actual fluid that you're talking about. Okay, what do I mean? I may be talking about the fluid flow, right? That is water. But when I measure the pressure head, I can be in meters of oil. Okay, so there are different fluid involved. Never mind, let's just talk about the key formula here, which is pressure equals to rho GH, which previously, if you remember your hydrostatic pressure derivation in my previous videos, pressure equals to density times gravity times a certain height, right? And this certain height, right, this height is the pressure head, and from here you simply move the density and gravity over, you get P over rho G. So this is your pressure head equation. It can be used in all forms of pressure. Okay, so converting between pascals to meters of fluid, this is the equation that you use. Okay, and it is you can see it from the page 14, that your say initially your stagnation pressure, right, is equals to static pressure plus dynamic pressure. We like to call this P total is equals to just P plus half rho U square. This is the equation in terms of pascals, but you can form this equation in terms of meters of fluid as well, by simply dividing both sides by rho G. Alright, so you will get this itself. Okay, stagnation head over rho g is your, stagnation pressure over rho g will be your stagnation head. And P over rho g is your static head. And this one, okay, is your dynamic head. That's it. Okay, so likewise, when we are talking about absolute pressure, it is gauge pressure plus atmospheric pressure, right? So if you divide by a rho g on both sides, you will also get absolute head, okay, gauge, and atmospheric head. Okay, so these two equations are similar to these two equations, except one is in Pascal, one is in meters, length of fluid. Right. Let's use an example to illustrate. Let's talk about example 1-5. So 1-5 is actually similar to 1-4. Okay, so it's also oil, velocity is also 3, and the static pressure is 25 kilopascal. So see, this is the fluid is oil. Okay, so the first thing you're going to find in part A is the dynamic pressure, which is half rho u square. Okay, half 8753 squared. Just now we find is 3937. 3937. Okay, let's say this is 3937 Pascal. Okay, but part A, right, actually asks you to express this dynamic pressure in mmHg. Okay, means it is a certain length of mercury. So we are actually asked to find, instead of finding the pressure in Pascal, you are supposed to find the pressure head in millimeters of mercury. Okay, so in order to convert from this to this, all you need to do is to divide the dynamic pressure by density and gravity. But density of what? This is the issue. Okay, density of what? Okay, if you are supposed to express in mmHg, then the fluid of expression is mercury. Okay, so this density is actually density of mercury. Whereas when you're calculating for the dynamic pressure, you're actually using the density of oil. So please do be careful. When you find the pressure, you're using the density of the fluid, but when you're expressing in terms of head, it can be in any kind of fluid depending on what you're asked to express. Okay, if you still can't get it, just rewind and rewatch this. If you still can't get it, ask your tutor. Okay, 3937, and this time the density we're using mercury 13600 multiplied by 9.81. Okay, so divide by 13600 divide by 9.81. Okay, this value 0.0295. These are all SI units, so eventually you're going to get an SI unit here, which is actually meters, okay, of mercury. But the question, you're asked to find millimeters of mercury, so you have to multiply by 1000 to get mm. Shift to 3 decimal place, you're going to get 29.5 mm of mercury, and this is the answer for dynamic pressure. Okay, so and then your total, okay, you can simply let it be dynamic plus static head. Okay, dynamic you already found is 29.5, the static head. static head will be 25,000 Pascal divided by rho G also. Okay, rho of mercury times 9.81. 29.5 plus, okay, let's see, 25,000 divided by 13,600 divided by 9.81. Again, this is in meters of mercury. You're going to convert to mm, it will be 187.4. Okay, times 1,000 plus 29.5. So the total head is 216.9 mmHg. Alright, and the question does not end here, because you realize that part B, you're also supposed to find head. No. But this time the unit is in meters of oil. Okay, it is no longer mm of mercury, it is meters of oil. So you use back the original dynamic pressure that you found. Divide by, this time you divide by density of oil. Okay, 3937. The oil is given as 875, 9.81. 3937 divided by 875. So this will be 0.459 meters of oil. That's your answer. Okay. You do the same thing for your static to get your total. 0.459. Static pressure is 25,000 meters of oil, 875 times 9.81. Okay, answer will be 3.371 meters of oil. So head, as you see, can be expressed in different lengths of different fluids. Okay, but the main fluid still comes from oil.